everybody. So brand new definition of a vector called torque. So if you have a force in space, let's say F, force F, then you say the torque by force F about some point in space. Let's say I have a point over here, point A. The torque by force F about point A is, you draw some position R. The torque, we'll use Greek letter tau, is a vector, which is R cross F. That's it. This is the definition. Right? And then this is meters. This is newtons. So the units are just Newton meters. Okay, so that's torque, just that cross product. And now notice, let's say if we use this example, the torque about point A would be, if you use your right hand and you go this cross this, which way is that? Your fingers would be curling clockwise. So with your right hand, if your fingers go clockwise, your thumb would be pointing into the page, and that's the direction of the torque vector. Now let's say I use the same force F, but now I have a different point. Say over here, point B. What's the torque by force F about point B? We go like this, R cross F, which if you use your right hand would be going counterclockwise. So if you curl your fingers in the direction counterclockwise, your thumb would be pointing towards your face. So the torque vector would be out of the page. Okay, so it matters about which point you're defining that torque. So it's always torque about some point. Okay, and now let's say, let me copy and paste. I'll just draw it again. So let's say you decompose vector R into two components. So I'm going to decompose vector R into one part perpendicular to force F and one part parallel to force F. Or, in this other example over here, let me decompose the force F into two components. One component parallel to R, one component perpendicular to R. Okay, so what I just wrote here on the left side, torque is R cross F, but I decomposed R into parallel, so this is torque, R, I decomposed it, cross F. Now let me do distributive property. R perpendicular cross F plus R parallel cross F. What's the cross product of parallel vectors? 0. This is 0. And then how about this? The magnitude would be this and this, sine 90 degrees, which is 1. Right? So then the answer, the magnitude is just R perpendicular times F, and then the direction according to the right-hand rule. So let me just jot that down. So the magnitude of this here is this times this. And then you just use the right-hand rule for the direction. This thing is called the lever arm. Okay, now let's look at this picture over here. Same story. Torque is R cross F, but in this example I decomposed F into perpendicular and parallel. Right, so let me do the distributive property, R cross F perpendicular plus R cross F parallel, and again What's the cross product of parallel vectors? 0. So the magnitude of this is r times f perpendicular, and the direction according to the right-hand rule. So let me show some examples. Let's say I have a bar that's kind of an L-shaped bar. Okay, let's say that's 3 meters and 2 meters. Okay, and then I apply a force here in the middle. So let's say 10 newtons. Just say right in the middle. Okay, so what's the torque about, let's say, point A? How would you do that? You could just go like this, R cross F. So in this particular example, let's pick coordinates. Let's say like this. Well, if X is here, Y is here, which way is Z? Out of the page, right? So that would be counterclockwise. So the torque about point A, you could just brute force do the cross product, where vector R is 1i, 3j, 0k. And then the force vector, 0i, negative 10j, 0k. And then just I direction, 0, j direction, 0, k direction, negative 10, minus 0, negative 10. Newton meters. And you'll always be correct. And in fact, if things are 3-dimensional, this is how you would do it. But in 2 dimensions, we can get away with, if you take a look at it, from point A, I can decompose vector R into 2 components. This one parallel to the force, this one perpendicular to the force. And we just established this parallel component doesn't contribute any torque, only this lever arm, which is 1 meter. So it's 1 meter times 10 newtons. And what's the direction? If you look at point A over here, right, and this is the force here, it's definitely going this way, clockwise. So clockwise is in the negative z direction. So negative. That's it. So that's easier, arguably, right? Okay, what's the torque about? Let's pick a different point. Here, point B. So R cross F, you could brute force, right? R would be, or like this, right? So you could just brute force cross product that thing. So I direction would be negative 1, I, and then 0j, 0k, and then the force 0, minus 10, 0. Do this cross product. I direction, 0, j direction, 0, k direction, 10 Newton meters. Okay. Or you could notice that vector is already perpendicular. It's already a lever arm, right? So it's 1 meter times 10 newtons. And then what direction is that? About point B, right? Point B is here. The 10 newtons is like this. So that's going this way, right? Counterclockwise. So your fingers go counterclockwise, your thumb is pointing out of the page, which is in the positive z direction. Okay, let's change this up a little bit. What about if I had a force, let's say like this, at some angle over here, 30 degrees. Okay, what's the torque about point A? It is like this, R cross F. And if you wanted to, you could decompose R into 2 components, right? One perpendicular to the force, one parallel to the force, and then this component doesn't cause any torque, only this one. So then, right, just, you would have to calculate this, which is maybe not so bad. Or another option, you can decompose F into two components. One that's, let's say, let me just decompose it like this, and like this. So what is this component? 10 cosine 30. What's this component? 10 sine 30. Okay, so now let me just erase this so we can just focus on it already decomposed. What's the torque about point A from this force? The lever arm is right here, 3 meters. Right, so it's 3 meters times 10 cosine 30. And that would be, from this force, is clockwise, which is in the negative z direction. So that's why I put the minus sign here. Okay, what about this force here? What's the lever arm? From point A, see this right here? This line of action? The lever arm is here, 2 meters. So it would be 2 meters times 10 sine 30. And that would be, right, point A is over here, the force is over here. So it would be going counterclockwise, which is in the positive z direction. So there you go, like that. Or you could just brute force, right, do the cross product, which would be, right, vector r would be here. It would be in the x direction 2, y direction 3, 0, and then the force, the x component, 10 cosine 30, y component, 10 sine 30, and then just do this cross product, right, and you'll get the same answer. Okay, so practice doing torque, and we'll have more to talk about regarding torque in the next video, so see you on that one.